If you've come to this video because you're looking for instructions on how you can migrate from Docker to Podman, you've come to the right place. This is the second video in a series that explores whether Podman is ready to dethrone Docker and whether you can use it for pretty much all of your different use cases that you have been running with Docker for the past period of time. I highly encourage you to see the first video in the series where we compare the Podman interface with the Docker CLI interface, and I demonstrated that we have almost 100% compatibility for the majority of the day-to-day use cases. In this video, I'm gonna dig deeper into the Podman backend and what's happening under the hood. I'm gonna deconstruct it a little bit for you. I'm gonna show you some differences between it and how Docker operates. And at the same time, we're gonna go deep into the details of how you can set up integration between Podman and Docker Compose. There's a lot of juicy information in this video, so I highly recommend that you stick around, and we're just gonna get started right away. As usual, I like to start with an architectural overview to make sure that we are all kicking off from the same information baseline. Containers are a Linux-specific technology, and container runtimes do not behave the same way on different operating systems, specifically on macOS and Windows. Podman as well as Docker require a virtual machine as well as a hypervisor. In that virtual machine, the containers will be started and ran. Let us assume that this box represents the macOS operating system, and I'm running macOS Catalina in this case. I have not upgraded to the recent versions. Whatever I'm going to show you today, I think is still relevant for the recent releases of macOS. However, for the MacBook Pros running the M1 CPU, the architecture might be slightly different. If we install Podman on macOS, probably using something like Homebrew, it will come with a number of dependencies. One of which will be QEMU, which is the hypervisor that Podman will be running the virtual machine on. Podman will use Ignition to spin up a Fedora CoreOS virtual machine. Once the virtual machine is up and running, Podman will generate a public-private key pair. The public key will be added to the list of authorized keys on the Fedora machine, and the private key will be retained by the host. Podman will then leverage Podman Connect, and it will rely on the private key that is on the host machine to SSH into the Fedora machine, where it will start popping up the different containers. This architecture means that whenever you issue a podman command on your host OS, which is the macOS in this case, this command will be relayed to the Fedora operating system VM, where the containers will be started, managed, and removed later on. You can obviously control the size in terms of memory of the machine as well as the number of CPU cores allocated for it. However, one of the major caveats of this architecture is that you will be responsible for making sure that this VM is up to date with the latest security releases or patches, because Podman does not take care of that for you by default. However, a workaround for this is you deleting this machine and then starting it up again, which will pull the latest releases of the Fedora CoreOS. And in short, this is how Podman behaves under the hood. Let us see it in action now. Let's start by installing Podman using Homebrew. And it's as simple as saying brew install Podman and just waiting for it to be downloaded and installed. And once that is completed, we can run podman -- version to see if it has been correctly installed and which version was installed. So we have 3.4.1 currently running on our machine. However, we cannot just start with the containers just yet. We need to initialize our virtual machine, as we said, running Fedora CoreOS. And we can do that with podman machine init. And this will initialize a very small virtual machine with one virtual CPU and I think 4 gigabytes of memory, if I'm not mistaken. But all of these parameters can be tweaked. You have additional parameters for Podman machine init. We can check them out while the initialization is happening. We can look at the help for this command, and you can see here that you can specify the CPUs, disk size, image path if you want to use another image, for example, and then the memory. I think by default it was 2 gigabytes and not 4 gigabytes. Yeah, you can see it here. Now, our machine has been initialized. The next step we need to do is to start the machine. It might take a minute or two. This is a VM at the end of the day. And with the machine started successfully, we can actually check on the status by saying podman machine list. And you can see here that we have the podman machine default already running with 1 CPU and 2 gigabytes of RAM with 10 gigabytes of disk space. We can also SSH into the machine by executing the command podman machine SSH. And as you can see right now, I am inside the Fedora CoreOS virtual machine. Inside this machine, podman is obviously installed, so you can say podman container ls, and you can see, for example, the list of running containers. Obviously, we have none running at the moment, but once we spin up some containers in the host, I will show you how you can find them also inside the virtual machine. In order to do this demonstration, I'm gonna start another terminal, and again, I am here on my host operating system, which is macOS in this case. You can see it from the different prompt. And here I am going to start a very simple Ubuntu container. So I'm going to say podman run-ti Ubuntu latest, and I'm going to run bash. You can see it has, the image has been pulled already. So we are simply starting the container. And as you can see here, I am already inside the Ubuntu container. If I go back to my virtual machine and say podman container ls, or you can say podman ps, you will be able to see that I have this container spun up running the image Ubuntu latest, the command bash 21 seconds ago, and the name of the container is exciting more. So if I launch one more terminal and I now inside the host OS, I run podman ps, I will be seeing the same exact results and as well as the name of the container exciting more. This is very cool because I think it gives you a lot of control in really understanding what's going on under the hood, and then you can customize your virtual machine pretty much whichever way you want. Docker on macOS does not really operate any differently than this, because if we go to the public repository for Docker, we can see here that they give attribution to HyperKit, for example, and HyperKit is the toolkit that provides hypervisor capabilities. And if we go to the HyperKit public repository, we can see here that it relies on something called the Beehive hypervisor. So HyperKit is a toolkit, Beehive is the hypervisor used by Docker under the hood, at least in the MacBook Pros running Intel chips. I'm not sure about the M1. I think they have switched to QEMU as well, but I don't have a final confirmation on that. Docker Desktop abstracts all of this away from you in a very nice fancy GUI and a very nice setup. And the update process takes care of upgrading the VM as well. With Podman, you have to do all of this stuff yourself. But in my opinion, it's just 3 or 4 extra commands and just, some random upgrades from time to time. I believe this is totally okay given the power that you have with Podman and the control that you gain with that. With Docker, I have not been able to SSH into the VM, but if you want to see the HyperKit process, you can run ps-af grep HyperKit, and you will see here, this is the VM spun up by Docker itself, where your containers will be running from. As you will see in a little bit, things are not very easy when it comes to Docker Compose and Podman compatibility, specifically on macOS. I'm not really sure how the behavior is going to be like on another operating system like Windows or Linux. I have not tested it there. However, on macOS, it has not been smooth. I'm still going to show you the instructions for setting it up and what the hoops that you need to go through to get something up and running. However, I'm pretty sure the outcome is not very satisfactory, especially if you rely and depend on Docker Compose a lot. For the simpler Docker Compose setups, things might run quite well. For the more complicated ones where you will have multiple ports to expose different types of builds that you need to run, things might not be that simple. And lastly, it's important to note that Docker Compose version 2 is not supported with Podman version 3 and above. You need to use the Python Docker Compose, which is version 1.2 or 1.29. This is the only version that I was able to get it to work.
work with my setup.
I normally use fish, but I'm gonna switch to bash in this case because I wanna make sure my instructions are as universal as possible. What I'm about to show you is very invasive and it's not really straightforward. I had to spend a lot of time going through multiple issues on the podman, Docker Compose, Docker repositories for me to understand the inner workings of these systems. The instructions I'm gonna share with you right now have the capacity to break your current setup. So you need to be aware and acknowledge that this is a very invasive and risky process. You might need to reinstall Docker or Podman or even both and reconfigure your system if you fail to go through these instructions, which are not foolproof. I'm pretty sure the developers and the maintainers of Podman are trying to make this experience a little bit smoother, but for now it is a bit rough on the edges. And the first thing we're gonna do is we're gonna initialize a fresh machine. If you have already one, please don't issue this instruction because it's gonna create a podman machine. If you have one that has already been running from the setup we've did a little bit before, just use that one. Don't create a fresh VM. Now that the machine is ready, we're gonna start it like we did before. Don't worry about these instructions. I'm going to include the link for them in the description below. You're going to have a gist with all of the information contained in it. Next thing we're going to do is we're going to try to SSH into the machine so that we can configure it from the inside. So now that I am in the machine, you can see here that I am logged in as the core user. Please follow these instructions carefully because I need to make modifications to the bash rc file on both the core user account as well as the root bash rc file. And what I'm gonna do is I'm gonna open this file for editing with VI, and then I'm gonna go to the bottom of the file and I'm gonna paste this new function. Now what this function does is whenever we issue the Docker command, it's gonna sort of reroute that to the podman sock. Be careful here that this is the path of the socket that we're gonna be using when the user is core. The path will change whenever we do the same edit but for the root account. With this, we're gonna save the file. Again, don't worry, all of these are gonna be in the instruction link in the description below. We're gonna now log in as the root account. Make sure that you verify that we have changed or switched the user. And the next thing we're gonna do is we're gonna again do the same change in the home bash rc file for the root account. And this time you need to make sure that the path is /run/podman podman.sock, right? This is to add sort of a workaround for a couple of instructions that are not available in Podman that Docker Compose expects. The next thing we're going to do is we're going to change a small instruction to start using the short name mode for images. Because I think in the first video I mentioned that Podman, for security reasons, uses more of a fuller image name. However, Docker uses the short name, only like the last part of it, and it skips the mentioning the registry in the name. This is a security feature that we're gonna disable right now in Podman, unfortunately, because it's necessary for us to get it to work with Docker Compose. So the instruction to do that simply relies on sed, and it's gonna replace this instruction, right? short-name-mode enforcing to short-name-mode-permissive in the etc-containers-registries.conf. And we're gonna hit enter. We can verify this very quickly by simply reading the content of the registries file. And you can see here the last line is now permissive. With this completed, we need to switch back to our macOS, and we can do that by simply just logging off. And now we are in bash again. I'm gonna clear my screen. Now we need to edit the config file located in our .ssh folder in our home directory. And this is needed because we're gonna have the Docker client connect to the Podman server that is located in the VM. And the way it's gonna be using that is through SSH. And we need to provide the Podman private key to this configuration and say whenever Docker attempts to connect to that VM, it needs to use this private key. And the way we do it is by configuring our SSH config file. We're gonna go to the bottom of the file, and then we're gonna add the following instructions, and we're gonna replace this over here with the name of the private key that is created by podman whenever you install it. Please make sure that this file exists on your home.ssh file before you add these instructions. And once you're done, you just simply save the file and the configuration will be applied. The next thing we're gonna do is we're gonna fetch the connection string basically from the podman configuration, and we can do that with podman system connections ls. And you can see here that first of all we have the rootless connection, and then we have the rootful sock connection. We're gonna be changing the Docker CLI to connect to the rootful socket, and the way we do that is by creating an environment variable. However, we're gonna replace the port value, and the value is 53781. Once we do this, we can verify it by saying env grep, and then we can say docker, and we can see that the value of docker host has been updated. Also, we can do echo and then $docker_host, and this is how we see the value of the environment variable that we just set up. Once we do this, Docker, the CLI, will connect to the podman backend, and we can verify this by saying Docker version, and you will see here the Docker client's version at the beginning. But then the server, you will see that this is Fedora 34, and it's connected to the podman engine now, as opposed to the Docker engine that is set up by default on your Mac. My recommendation here is to make sure that you have Docker engine stopped, so that you, whenever you do these tests, you are running them in isolation and you don't fall into the trap of thinking that it worked while your Docker client is still connected to your Docker engine as opposed to the podman backend. I'm gonna clear my screen again, and I'm gonna clarify here that Docker Compose comes pre-bundled, or Docker Compose version 2 comes pre-installed on your machine. So if you say Docker Compose -v, you'll be able to see that it is version 2.0 on this machine, just because it comes part of the desktop app that I have installed. Now, before we continue with the setup, we need to get some Docker Compose samples so that we can test our setup with. And we can do this via the awesome Compose repository that is available publicly. We're just gonna simply clone it to our local machine, and we can do that with a git clone, and then we pass the URL. Next, we can go into the awesome Compose directory, and we do a quick listing of the files. You see that we have multiple projects that we can use for testing purposes. Here is a good place for me to do the setup of Docker Compose, to be honest. And the way we're gonna do it is, because I wanna create sort of an isolation for myself and I don't wanna pollute my host environment, I'm gonna use virtual environment to create a sort of a sandbox where I can install Docker Compose on for testing purposes. And once you are comfortable with this test, then you can install the version 1.0 of Docker Compose on your system, or you can replace version 2 with version 1. But for now, I'm going to create this sandbox. And what I'm saying here is I want to use virtual env. If you don't have it installed, you can install it with the pip. And I'm going to specify which version of Python I want to use. So which Python 3 basically fetches the path of the Python 3 interpreter in my system and then feeds it to this parameter. And I'm saying also that I want all of the files for the sandbox or the virtual environment to be located in this .venv folder in this path that I am in right now. So this virtual environment has been created quite quickly, and we can, if we do a listing of the files, you'll be able to see here that I have the folder created. Now we need to activate it, and we can do that by saying .venv bin, and then we can say activate, and this will activate the virtual environment. And now I am running my instructions inside the sandbox. I'm gonna clear my screen one more time, and here I'm gonna say pip3 install Docker Compose, and this is gonna install Docker Compose version 1.29 in my sandbox. And once this is completed, I'm gonna clear my screen one more time. You can verify this by saying Docker Compose -v, and you will see that the version has changed now to 1.29 2. Once we have this in place and while the virtual environment is running, we're gonna pick a project from this awesome list of Docker Compose sample projects, and we're gonna go for maybe the React Nginx project. So let's see how that one will work. We're gonna go inside the directory. I'm gonna clear my screen one more time, list the files that are in it. We see here that we have a Docker file, we have README, we have a Docker Compose, we have a bunch of folders. So let's go through the README and see the instructions. It seems to be a very simple setup whereby we can say Docker Compose up-d, and we should have all the images and the networking done in between them, and it is being exposed on the port 80. So yeah, let's try this one out. We can say easily Docker Compose up-d, and let's see what happens. Now what's happening over here is that it's not Docker that's really building these images, it's Podman that is actually doing that.
A few moments later.
Great, I'm very happy that we got this error because I want to show you one last instruction that we have to do. If you get this error, server did not provide an image ID, this is because Docker Compose uses the Docker CLI by default when executing a certain build, and there's a compatibility error over here. So the last instruction that you need to do is you need to add this environment variable to prevent the Docker Compose from using this Docker CLI for builds. And then you can do a Docker Compose up-d one more time, and you should not have this error anymore. And now I'm gonna clear my screen and I'm gonna do a Docker PS, and I should be able to see the containers up and running. And if I go to localhost, yes, perfect. I have my application up and running, and this is how it should behave. Of course, the other Docker Compose commands should be working fine as usual in this case. Like Docker Compose down, it has removed basically the container as well as the network that it has created. And if we run Docker PS one more time, you should see that the container has disappeared. One quick verification also, this page is not up and running anymore. As I mentioned, I'm going to be including these instructions in a gist in the description below, so you can run it, follow the instructions step by step, and you should be able to get this environment the same way I did up and running on your macOS. I hope you found this material useful and I was able to share with you some valuable information. I want you to always remember when comparing an open source solution with a product that is backed by a multi-million or a multi-billion dollar company, that Podman is created by a bunch of volunteers, right? So you cannot really put it at the same level or same standard as Docker, for example, which has many, many, many highly paid engineers working on it. And for an open source project, the results are pretty impressive, to be honest. And I think this setup, even though it's a little bit more involved, I think it can definitely be automated in a certain way. And if the Podman project had more volunteers and more developers working on it, I'm pretty sure this is a solved problem already, and they will not have these issues at all. This is the second and final part of my Docker versus Podman series. I don't think I'm going to be making a third video just because I think we covered it all. I'm not sure there's any more interesting content to cover. Obviously, Podman has a lot more features that are very, very interesting, especially for engineers who are using Kubernetes also, or if you are deploying your containers to Kubernetes, because Podman has the concept of pods and the automatic generation of the pod manifests that you can capture and just throw in your Kubernetes cluster and run your containers right away. Docker does not have that capability. But also Docker has a lot of features that Podman still is yet to be able to support. If you like this video series, please hit that like and subscribe button. I really hate saying it, but it's just, I don't have any upside out of these videos except you and your support, which I highly appreciate, and I really, really love seeing your reactions to my videos, reading your comments, and even responding to them. My name is Bassem, and until next time.